What is blockchain? Simply put, a blockchain is just a chain of blocks containing information. So what problem does blockchain solve? Blockchain was originally created as a way to timestamp documents so that they could not be changed or altered, or that the timestamp could not be altered. It creates effectively a distributed ledger, which keeps track of all changes to the document and then shares all those changes freely and openly among a network of computers. The transactions are broadcast to all the nodes in the network, and once validated, they are recorded in blocks. What is a block? How does this work exactly? And is this secure? A block is made up of three things: the data stored in the block, which might be a Bitcoin transaction, for example, which would have a from address and a to address and an amount; the hash, and the previous block's hash. What is a hash? A cryptographic hash is a way to create a mathematically unique number, like a digital signature, and it's calculated using the data within the block. So you cannot change the contents of the block without changing the hash. And also, it includes the hash from the previous block. And that is how the chain is created, because the previous hash's information gets merged in with the new hash, and that links them together. Here is an example of how the hash function works. The first block is called the Genesis block, and so it doesn't have a previous hash, but it has a new hash based on the contents of the block. Then it chains to a new block when a new block is created, which includes the data of the new block plus the previous hash from the previous block and calculates it into a new hash. And this way, the state of the blockchain is carried on from block to block. Any change in a block will change the block's hash and therefore will cause all subsequent blocks to be invalid. When somebody tries to change a record in the ledger, it changes the contents of the block. Therefore, it changes the hash of the block. And that changes the hash of all subsequent blocks. So the other network nodes will notice this and reject your block. The only way that this would work would be to recalculate all of the hashes. Unfortunately, computers are able to calculate hashes extremely quickly. So, in order to increase the difficulty of creating a new block, proof of work is required. And essentially within Bitcoin, for example, the hash has to be generated with a specific pattern at the beginning. Otherwise, it is not acceptable. And so it makes it more time consuming to create a block, and it makes it much harder to tamper with the blocks because it takes such a long time to recalculate a hash with the proof of work. We also need to distribute the blockchain ledger to enhance the security of the blockchain. The blockchain is distributed over a peer-to-peer network in which anybody can join, and all of the nodes have a copy of the blockchain. They use that to verify that the hash has not changed. When a new block is created, it is sent to everybody in the network. They verify the new block, and if it is legitimate, it is added to the node's blockchain. The blockchain software combined with the network creates consensus. The nodes in the network agree upon which blocks are valid or not. Invalid blocks are rejected from the network. To tamper with the blockchain, you would have to alter all of the blocks on the chain. You'd have to redo the proof of work for every single block, and also control at least 50% of the peer-to-peer network. Blockchain technology can be used for creating electronic cash, tracking land ownership, ensuring the voting records are legitimate, and for fundraising platforms. Much of these use cases are implemented through smart contracts, which are really just computer programs that are stored in the data of the blockchain. They can be used to automatically exchange tokens based on conditional rules. And it is a distributed ledger that stores electronic contracts. Here's an example. How about we create an automatic insurance policy? So let's create a smart contract for insurance. First, we will predefine our contract. The terms will be agreed upon and then coded into the contract, which will be applied to the blockchain, which makes it immutable or unable to be changed. When an event occurs on a property, for example, it triggers the policy execution, in which the smart contract goes into effect. The policy's terms are automatically executed. And then once everything is met according to the standard of the policy, the payout is completed. If it does not meet the terms, the payout is not completed. Smart contracts are secured because the smart contract code cannot be altered. It is applied to the blockchain and cannot be changed without changing the hash. And it is distributed. Therefore, the contract is validated by everybody on the peer-to-peer network. Here are some use cases for smart contracts. Self-servicing loans, automating payment systems, and the handling of insurance claims can all be done through the correct implementation of smart contracts. That concludes my presentation on blockchain and smart contracts. I hope that it was beneficial to you in your journey of understanding blockchain.